Well, good morning all of you. So this is your second day. Yesterday you had your first day. So today we will try to cover what is the course content of your 2-year course. So that's how I titled the presentation as the purpose, philosophy, principles and methods of industrial engineering.
Please.
So the first portion, I am showing you a presentation that I did recently in an international conference in the University of Pittsburgh. Why I am doing this presentation is to emphasize that industrial engineering is useful in all branches of engineering. There are multiple branches present here. Probably I don't know whether any mining engineering student is there, but this happens to be a presentation of mining engineering because the conference was on coal. The conference is concentrating on the coal mining and the utilization. So this is the title of the paper, Industrial Engineering and Productivity Management in Coal Mining and Utilization. This is the flow of presentation. Right. So what we are trying to say is, industrial engineering focuses on economical efficiency improvement of engineering systems. Yesterday, in one of the batches, Director Madam is telling innovation, new products. Right? Now, what happens when somebody makes a new product? One engineer gets an idea and he makes a new product. Does it become a commercially successful product immediately? Does it become a commercial product immediately? Now many times they say there are many patents are given, but most of the patents are never used. Why they are not being used? Because they are not accepted in the market. They are not accepted either because the people don't like the service that that particular patent is offering. The product in the patent is offering a certain service, right? But they will not like it. Other thing is, they like it. And they say, okay, we will buy it if you can sell it at 1,000 rupees. And the manufacturer says, no, it cost me 20,000 rupees. How can I sell you for 1,000? So you keep it. I can only give 1,000 rupees. So this you are going to see in your economics course, where they are going to say, the customers decide the demand. The customers are going to say, this particular product we are going to buy at this particular rate and this particular quantity. Right? So if you are able to sell it at that particular rate, then only you can sell that particular quantity. That means your cost of production must be less than the price that the customer is offering. Now this is what I am going to aim at when I am saying the industrial engineer focuses on a product which is designed by an engineer. Customer is happy with the product. He likes the service, but he tells you, okay, I am going to give 2,000 rupees, 5,000 rupees, 4 lakhs, 3 lakhs. How to make it within that price? So this becomes the focus of industrial engineering. So when you take any branch of engineering and you want to give that branch of engineering makes a product in that branch of engineering, to be electronics product, electrical product, or mechanical product, right? But when it comes to seeing that an industry comes into existence, a commercial industry comes into existence, then there is a role to play to the industrial engineers. So by deduction, I say it is applicable in all engineering branches. Is it being used in coal mining? That is also an engineering activity, and that is the focus of the paper. Right. So once again we give the same point. What is engineering? It is design of products, components and processes, and of course the subsequent production of the particular thing, the servicing, maintenance, testing, all those things are coming once you are getting into the design of the product. And industrial engineering, I try to explain as system efficiency engineering and human effort engineering. This is where we are talking about the purpose of industrial engineering. Purpose of industrial engineering is efficiency improvement. An already designed engineering system is there, and you should be able to increase its economical efficiency further. Yeah. The other thing is the human effort engineering. This is something special to the industrial engineering branch. Other engineering branches don't concentrate on the people who are working in that particular field of engineering. And here we are talking of the whichever of the people who are working electrical engineering, wireman, whatever people are talking of civil engineering, the construction workers. So how exactly they are going to do their effort? Industrial engineering is engineering-based management activity. We already said it is increasing the efficiency of engineering systems. The other thing is we are trying to say it is a management activity. Why we say management activity? Because you want to set up an industry. That is why you are doing industrial engineering. So when you are doing industrial engineering and making a product cost less than the price willingly paid by a customer, you are a part of the team which is creating the business. When you are saying entrepreneurship, yesterday we were talking of entrepreneurship. And entrepreneurship comes only when I have a product which I can provide at a cost less than the price the market is willing to pay. And an industrial engineer is a part of the management because of that. It is, if you say management is a big subject and there are hundreds of subjects below that particular thing, industrial engineering also becomes a subject of management. But what is the basic discipline which drives it? Engineering. Some other subject may say psychology drives me, some other subject may say accounting drives me, some other subject may say economics drives me, but industrial engineering is driven by the engineering knowledge. Right? So industrial engineering always has value in all branches. This is a particular point you are saying. What is the focus of industrial engineering? Improvement of efficiency or productivity, and if you increase efficiency or productivity, immediately cost comes down. This is what we are trying to say. The cost of production comes down whenever you improve efficiency or productivity. So what are the methods which are there in industrial engineering? You can identify 8 areas. Right? The first one is the product design efficiency improvement. This is what we are trying to say. So somebody invents a product and makes initial design. You go and change that particular design. Right? And to change the particular design, you require the engineering knowledge. Without having the engineering knowledge of the branch, you cannot go and change the design. You are going to go through a design iteration. But this design iteration is driven by certain efficiency focus. If you have to improve the efficiency of this product, what you are supposed to do, right? There is a way of thinking. There is an efficiency way of thinking which you have to bring into picture, combine engineering knowledge and create that. So there is one subject which is totally based, to a large extent based on the engineering knowledge. The second one is the process efficiency improvement. Once again, we are looking at the engineering side. It can be production process, inspection process, maintenance process. So whatever are the processes, once again the engineering knowledge is there and efficiency thinking is combined with engineering knowledge. So these two subjects in industrial engineering, or these two methods are driven by the engineering knowledge. The third subject is the product and process optimization. Now these particular things have come from the mathematicians. Mathematics and science combined, and we know it more popularly as operations research. Right? Now this particular subject is to be used to optimize engineering products and engineering processes. There are books like engineering optimization. They are already in the market, titled as the engineering optimization. So here you are looking at combining the knowledge that is developed in the optimization area of the mathematics and related fields, and you want to combine with the engineering knowledge. But by the moment you move here, there is a role of management comes into picture. Right? We will see in a subsequent slide where the management comes into picture, right? Where industrial engineers are going to go and look at the management process, change the management process from the industrial engineering perspective. The next one is statistics. Now statistics are also used in industrial engineering. There are certain developments in statistics which you can use to reduce costs. Once again, there is a combination of the engineering and the statistics which come to picture. Today one's very popular thing is called as a Six Sigma, right? Where you are bringing so many engineering parameters, doing some experiments and trying to say the best parameters are this. If I use these parameters, I will get a good quality of finish, right? My cost will come down because my defects are going to be reduced, right? The next one is the engineering economic analysis. Here, what sort of thing we told the economics, right? We said there is a theory in economics which talks how the demand is created in the market. So that theory tells you at this price, this much amount of quantity is sold. Apart from that, in economics, there is something called production economics. What happens to your costs as certain decisions are being changed, right? And engineering economics mainly we are focusing on that as an engineer, as an industrial engineer, any proposal you make in the company, either for long-term investment or for a short-term expenditure. What is a short-term expenditure? Let us say you say, let us increase the quality of the lubricating oil. If you use the quality of the lubricating oil, our machine maintenance cost will come down. It's a short-term expenditure, right? But you are increasing. You are spending earlier say some 100 rupees per liter. You say let us spend 125 rupees per liter. If you spend 25 rupees per liter, your cost reduction should be 50 rupees somewhere. So you should be able to show that because we are spending 25 rupees more on a daily expenditure on the lubricant, I am going to save 50 rupees expenditure. The other thing is, you may say, let us buy a robo, cost 25 lakhs of rupees. But if you buy a robo and use it for 10 years in the company, same principle comes back. That if I buy 25 lakhs of robo, I must get a savings of 50 lakhs of rupees. Right? You should be able to show that particular. Now this is the main focus of engineering economic analysis. So where you can say broadly, all capital expenditure proposals in the company, they are subjected to engineering economic analysis, right? So you can see two obligations for industrial engineers. One thing is your own proposals being properly supported by the engineering economic analysis. Then other engineers' proposals, if you think they are not that much conversant with the economic issues, additionally, because you are having the efficiency focus, so if the proposals come to you, one side is you look at the engineering economic analysis, other thing is it efficient? If it is not efficient, you are going to put your efficiency inputs into the proposals. Anyway, that is your job. If there is an IE department is there, then companies should refer all proposals made by all engineers first to the industrial engineer people, because they can discuss with the engineer people in a more easier manner compared to a non-engineer looking at a financial analysis. An engineer looking at a finance-oriented analysis will be able to interact with the people in a better manner. Right? Then we are talking of the human effort engineering. What is the human effort engineering? Whatever are the movements we are doing with our hands, with our legs, with our body, and doing a work in an engineering system, that work can be improved. There is something called as a principles of motion economy, which are developed long back, right? Which can be applied, and the output of people can be increased. Right? And then we have a subject called as ergonomics, which is the study much more from the problems that workers get when they are working repeatedly in a given work. Right? And you need to combine it. Right? The third thing is fatigue. Right? I give a lecture for 2 hours, then we'll explain. Right? You stand and give. You don't feel like sitting and giving. You stand and give. Okay, but then. Right? So there is this area what is called as a fatigue. So an industrial engineer should understand when the worker gets a fatigue, how much time he needs to rest. Long back itself, Taylor, who is considered as the father of industrial engineering, he said 53% rest and 47% work. Right? But in 8 hours, if you observe, the fellow takes 4 hours rest and only 4 hours works. And that is the optimal for a certain type of work. Right? So the industrial engineers are to that sort of a study they have done long back, that what sort of a rest and work system will come. Right? Sometimes we see, I go to a company and the worker says that after lunch I won't sleep for half an hour. And my MD also sees me and he doesn't say anything. We are lost. But then when you know this sort of a thing, this fellow is allowed a 4 hours rest. If he takes in a concentrated manner and goes and takes 1 hour sleep, it doesn't matter. Once we understand it, the type of rest he is taking, you are not going to be that much disturbed. You have to understand the principle. But sometimes you may say, no, every 15 minutes only you can take rest. Every 15 minutes you are going to work. Okay. Then he sits in the chair and sleeps. That also you have to agree. If that fellow sits in the chair and sleeps. So there is a certain amount of content in that particular component of human effort engineering. There we also talk of the compensation. Right? It is not only a question of getting more output from the machine or the man, but from the output which is coming, a proper share would go to the man, whoever is working. So engineers, long back industrial engineers have observed this particular thing, and that's why Taylor has said in his book quite early that high productivity and high incomes go together. You cannot get high productivity from workers and pay very low wages. What the worker will do? He will move to some other company which is willing to pay him higher wages. He already has some idea how to give higher productivity. Why should he give that productivity to you and take the low payment? He simply walks away. Then we have measurement. Now measurement is an important thing in all engineering branches. Right? Your design is always based on the measurements. Measurement decide the design. So in this case also, at least 3 areas we are talking of is the work measurement. Wherever you are saying I improved, the worker is earlier taking 3 minutes, he must take 2 minutes now. Right? There has to be a measurement which says that earlier he is taking 3 minutes, now he will take 2 minutes. We say cost reduction, cost measurement has to be there. Earlier this product production cost is 2000, now it is only 900 rupees, 800 rupees. You should be able to measure that particular cost because you are focusing on the cost reduction. So similarly, what we say as a productivity. Right? Multiple measures of productivity are there, especially all resources that the production system is employing. You are going to calculate productivity of each and every resource. What is output for my acre in area? What is output for machine? You can measure output for even the how many fans you are putting, right? Measure the output of AC, how much AC you are putting. Right? Whatever is the resource which is being identified, you want to measure the output of that particular resource because you want to improve the productivity of that particular resource. Today you know, right? We are trying to LED bulbs. We are giving a sort of a certain discounted rate. The government is supplying to the people, saying that people should use LED bulbs because the power consumption will come down. So we are doing that sort of an exercise that within a less wattage, we should be able to provide lighting to the more houses. And the last one is the productivity management. When you say that particular measurement has to become the management. So whatever you are measuring, you should be able to manage. So what is manage basically? Manage is we start with the planning and end with the achievement of the plan. Right? You say my output cost will be 800. So have you come to 800? The target initially is that we should be able to pay 800, then it has to come to 800. So multiple activities are there. You need to plan those activities. You need to create an organization. You have to create employ people. You have to get the resources, actually use people and use other resources, and you should actually get the output. So the management component is basically dealing with that particular thing. How do you start with the plan? and completely put the system in place and run the system and get that particular output. So industrial engineers, first of all, basically are responsible for their objective, which is the productivity of the cost reduction, right? And then managing the IE department. The IE department to 10 people, 15 people, so still somebody has to manage that particular department, right? So there are two important purposes of the management component in the IE curriculum. One thing is how to manage productivity in the company, and second thing is how to manage your own IE department. Then I am just talking of the applications of IE in mining. Quickly we will go through. I say a long back there is a question of engineering economics where we are talking of the how to do the hauling of the coal which is produced, what are the alternatives and what is the benefit of which thing is a better. Next. Right? Then the process efficiency improvement and work measurement is saying in 1958 there is a master's thesis on this particular topic. Then of course the Six Sigma is there which is being used in the coal mining applications also. Right? Then of course the optimization, and recently I am just talking about PwC consultant, it says that you require a model which is going to connect, let us say, engineering parameters with the cost. So that if I want to reduce the cost, what engineering parameters I must be able to change. The mining parameters and the cost should be linked, and you require a model, a cost model which is going to link that particular this one. But there is a earlier paper, when I am writing this paper, where they are talking of the application of industrial engineering and mining. So my paper also says that yes, you see already that in mining there is enough application of industrial engineering. Okay. We come to the Indian condition. Right? We also have a certain studies in the India also in the mining and industrial engineering. And then when you see the material on the coal related to coal mining, you do see that there is the coal ministry's website. If you go, you see the emphasis on productivity. You go and see the Parliament of India, certain questions asked by the members in the Parliament on the productivity. There is a country on the public sector undertakings in the Parliament, that also talks of that. Then the agreements between the Coal India and the workers, it also talks of the productivity. That means there is a productivity focus is there. Productivity is an important thing in the industry. That sort of an awareness is there. Then there is a question in the Parliament, and you are seeing a multiple things told that we are doing various steps to increase the productivity of the coal sector, various technical sort of things, and some things connected to the human factor also, like training the people in the use of the new technology, etc. Right? So this is the sort of our coal mining sector, important companies in the coal mining sector. We have the Coal India, and Singareni Coal is a separate company, not a part of the Coal India. And we have Naval Integrated Corporation, which is another sort of a separate thing, and they take the whole majority of that. Industrial departments, of course, they are there in Bharat Coking Coal, and the Singareni Coal is the Naval Integrated that. Right? The only problem is when you want to see what are the achievements of this IE department, right? And you are not getting any sort of a clue in the entire internet. You try to see that what sort of achievement the IE departments of these people have done, you don't see a sort of anything. That means the IE departments are not that much active to publicize their achievements through their websites. So what sort of a judgment we can do? Yes, efficiency important, efficiency improvement is important, along with the effectiveness improvement. What is effectiveness? Effectiveness is when the customer is accepting your product technically. Yes, your product is working, it is useful to me, but I am going to give only this much amount of price. Huh? Why does he say he gives only this much amount of price? Because he compares with an alternative. I go out, somebody says I'll take in a car, how much I'm going to pay? I'm going to pay the taxi fare. If I know the taxi fare, I know the alternative. So I know taxi fare costs this much to me. Or I know what is auto fare cost this much to me. So immediately there is an alternative thing, and I am going to compare with that alternative way of getting that same service, and I am going to give that particular thing as my figure. Industrial engineering is specialized discipline in engineering branches with the focus on this one, right? Industrial engineering is done in this particular thing. Now the question we are trying to say is that you don't still see a very systematic use of the industrial engineering in mining. We have an Institute of Mines right in India. Where is it? Right? Now they are changing it to IIT. They have an industrial engineering program. I just tried to see their website. There is absolutely nothing like industrial engineering in mining. You don't even see a subject. They talk of many other things, but not the mining. And then probably go into see the mining engineering courses. They may also may or may not be talking about the industrial engineering. So the need is that for a systematic application, you need to have a subject properly in both IE curriculums and this curriculum. Right? Then there has to be cooperation between the industrial engineering faculty and mining faculty. Same thing occurs everything. You require cooperation between some industrial engineers and mechanical engineers, some industrial engineers and electrical engineers, some industrial engineers and electronics engineers. There have to be a sort of a specialized groups of industrial engineers who then deal with the technical side of it and try to achieve this particular work. Right? Then the point we are trying to say is the total cost industrial engineering. This what we are saying is the industrial engineering department should be able to go to a company, big or small. You go to a 10,000 crore company turnover, its company's costs are 8,000 crores. You know balance sheet is there. On April 1st, you know last year cost is 8,000 crores. For next year, how much you will reduce? This is the target you have to create. And that is what is the productivity management we are trying to say. The productivity management is planning the cost reduction target. If 8,000 crores is there, how much I am willing to commit to cut it down? 1%, 2%, 3%, 4%, 5%. What is it that I am trying to commit at the entire country? It seems there are some companies, maybe very few, who have a target of cutting 5% every year. And they have done it over a period of 20 years. A long period of time, they are able to cut their cost by 5%. So we are talking of India 10% growth, right? Double digit growth, 10% growth. So if you can cut 5% cost, it's a growth. Right? Growth is going to come where? In the value added. Right? Since last year value added is revenue minus cost. If you can cut 5% on the cost, it immediately becomes the value added. Right? So the 5% target is a very, very short-term significant target. That how many companies can take and systematically cut the cost every year by 5%. Right. Now this is where I am trying to come and say, so when you say that 8 different types of methods are there, right? 2 methods are on product and process based on engineering, 1 method based on the mathematics and operations research, 1 method based on the statistics, 1 is based on the engineering economics, 1 we said is human effort engineering based on the IE of principles of motion economy. Then you are getting the ergonomics aspect you are bringing into the picture. Then you are bringing the income of the workers also into the picture. Then we are talking of the measurement. We have to do the measurement of the objective that we are talking of. Then the productivity management. So you have said the 8 different areas which are there. Now where they are applied? So when where they are applied, I say the core for an industrial engineer as an engineering based man is the technical process. The technical process of the branch, the products of the branch and the process of the branch. So this is the core which you are trying to first of all change. Change to increase the productivity. Reduce machine use, reduce power use, reduce material use, reduce the human use. Whatever you are talking of the reduction, right? The second thing is there is a managerial process used to manage this technical process. Right? The technical process requires a managerial process, management of design, management of production, right? Management of inspection. Everything has got a process. Now that process needs to be investigated because it may be the reason for the low productivity. The reason for the low productivity could be the managerial actions. So as a person who is focusing on productivity, whenever you come and feel that it is the managerial process which is giving the low productivity, you are going to make a suggestion and say that please change the managerial process. Right? So you are entering into the management activity and trying to figure out whether managerial processes are giving the low productivity. Similarly, once the industry engineers succeed in a company, in any technical process, so naturally people will feel if we can go into some other process, also efficiency can improve. So the next additional responsibility becomes the business process. For the business process, engineering is not the main discipline, right? But they are calling you into the business process because they feel these people are made the technical process efficient, so why not business process? They are studying the business efficiency, applying it effectively to the technical process, so why not to call them to improve the business process? So the same logic, it goes to the managerial process of the business. In marketing management, marketing is a business process. The marketing salesman or the market researcher has to work like a shop floor worker. He doesn't become a manager because he is a part of the market. Right? The marketing management is managing the marketing process. The marketing management is different, marketing road work is different. Right? Just as production management different, working on the machine is different. So there is a difference between the management and the actual work that we are doing. Before that, why I am showing this particular thing to you is I am going to take the industrial engineering and productivity management paper for both section A and section B. Right? So when I am going to come to that class, so I have created a large number of articles on the industrial engineering subject in the last 3-4 years. So I am just giving this particular thing as an indication to you, and I am going to circulate this presentation immediately. I am going to circulate this presentation to all. That includes. But so these are the techniques once again. I want to little bit cover detail. Okay. So when you are talking of the product design efficiency improvement, what sort of some themes or some sort of a established techniques I can tell you is we have something standard subject called as time and motion study, right? It is also called as a work study, and you are going to get a test book on that particular thing. So within that time and motion study, some issues are covered. How you are going to examine the product design, that issues are there. But there is a subject called as a value engineering, which was developed by an engineer working in purchase, right? L.D. Miles was a General Electric. He developed a subject called as a value engineering. Now that becomes the main subject which focuses on product efficiency improvement. Then we have something called as design for manufacturing. The designs have to be evaluated from the manufacturing use point of view, and design is to be modified. Right? We have something called as a design for assembly, and probably your people are calling it design for X. Now there are so many things have come: design to cost, design for improving maintenance, various sort of things have come. So you people are talking about a design for X. We have recently a new name called as a lean, right? And there is something called as a lean product development, right? And another name called a product development Kaizen. So these are the various themes of the various topics within this particular subject. And within your 2 years, somewhere or other you are going to come across. In some or other subject, you are going to come across these particular ideas. Okay. efficiency analysis, right? Where I am just trying to say that the process efficiency analysis is improvement through engineering changes, right? This is what I want to emphasize that particular this way, right? Which means that you need to improve your engineering further in these 2 years, and when you join a job, you have to improve engineering much further. Why? Because suppose that man is M.Tech welding or M.Tech forging, right? And you want to discuss with him with your B.Tech level knowledge, right? Is he going to listen to you? The probability that you will give good suggestions is also very less. Right? Against a man who has done an M.Tech in that particular sort of advanced subject, and you want to tell him with your B.Tech level knowledge, the problem is not there. So you need to upgrade yourself after you join a job, because then you specifically know, okay, I am in this particular company whose major engineering discipline is this. So very quickly you need to increase your knowledge so that you can do a proper job of interacting and changing the designs done by those postgraduate people and the research sort of people. Right? First thing is operation analysis. We are going to look at it. It's a full book is there on operation analysis. And within that, I just put the SMED and Tokayoke. There are 2 new industrial engineering techniques which were developed in Japan by Shigeo Shigo as a part of the industrial engineering, as a new industrial engineering. Right? The method study is a part of our time and motion study. Right? Layout improvement is also a part of the process improvement. Maintenance improvement, right? You want to increase the productivity of the machines. So the maintenance becomes an important activity to improve the productivity of the machines. You should do the maintenance in the right time. You should do the replacement in the right time of the machines. Right? Energy productivity improvement is a very, very important activity today. Right? Probably it is happening independent of industrial engineering profession, because the Bureau of Energy Efficiency is totally different. They have an All India exam, energy audit managers. They have a completely sort of a different sort of a setup is there for the energy efficiency improvement. Internationally also there is a energy efficiency improvement activity is there. Right? Automation is one of the ways to improve the productivity. Right? Right? Now when you come to the optimization side, right, you look at things like cost minimization and product design. Right? There are so many sort of over applications in the design. When you want to say what should thickness of the material, what should the dimension of a particular shaft. So various sort of things are optimize the use of the over application. Right? You're deciding on the number of machines. Right? How many machines of each variety we must have. That particular thing could be decided by a queuing theory, depending upon what is the ideal time allowed for the job that you are going to have in the process of this thing. Allocation to operators to minimize the completion time. So in the company, certain operators develop certain efficient ways with certain components. So the person who is doing the scheduling should be able to know, if I give this job to which worker, it gets done in a faster time. Something even faculty, right? Institute faculty, they have their own specializations, and certain subjects they teach very effortlessly, and certain subjects they teach with great effort. So somebody has to know, that's how the timetable making comes, which faculty goes to which subject. Right? The assignment problem. The plant layout improvement problems, once again, they are done through the war models. Right? The cost minimization in the mechanical handling and transport. Right? Today you are saying milk runs. Yesterday only people are doing a particular project, and what he says is a computer, probably the computer side, he says the company is taking 4 days to do the calculation, and he suggested them a method in which you can only do 20 minutes. That is a summer project of one of the students. Yesterday he is telling. Right? So, improvement on the software side. Right? If you are taking for 4 days to do some particular, whatever is the reason, you change the algorithm and you put a new algorithm, and you are getting it in 20 minutes, and probably you are getting a better output in the case of the transport plan. Right? So in the case of statistics, one of the simple applications is sampling. inspection, you are doing 100% inspection, you don't have to do, you go for a sample-based inspection. If you take only 5% sample, 90% is avoided. So the statistical quality control became an early application in the area of industrial engineering. On the statistics. Same way, the statistical process control, automatic machine is there, we have to change the setup. But when are we going to investigate and change the setup? So it was a problem, but once the statistical process control has come, you said every 1 hour, you go and take 5 items, take a measurement and put a chart. The chart will tell you when you are going to do the setup investigation. So your anxiety has come down, your problem has come down. Right? Work measurement. In work measurement also we use the statistics, and we said instead of doing 100% work measurement, go and do only work sampling. You don't have to stand before the worker for the full day. You only go 10 times or 15 times in a day, observe the worker, and you are able to come with the standards. Right? Now the Six Sigma is a very, very popular subject. Right. This is a long back. The person, ASME chairman or a president, he said, there are good engineer. You are a good engineer if your design works. Many times you design, the prototype may not work. Right? So you are a good engineer if you are able to make a design which works. Right? You are a rich engineer only when you are able to produce an effective engineering item at a cost that allows a profitable price that a large number of customers are willing to pay. Right? Refrigerators, every house must have a refrigerator. Very good. That means 50 crore people have to buy in India, and 50 crore people are going to buy it 4,000, 5,000, whatever that number. So you make a refrigerator 25,000, it doesn't. Right? So you become a rich engineer only when you are able to reduce the cost. Right? So that is why the industrial engineer comes into picture, where we say he is the man who can make the farms rich. He is the man who can make societies rich. Every house can have a refrigerator, provided proper industrial engineering is done. Right? That's how the mobiles have come. Today you see everybody has got a mobile. Right? Housemates have a mobile. The Ragdi fellow has also got a mobile. Everybody says, he gives a mobile, says, please give a ring on the mobile. Every mechanic says, give a ring on the mobile. Right? How it has come? Because in 600 rupees mobiles are available. 300 rupees also in the second-hand market, there the mobile is available. A tremendous cost reduction has taken place in the mobile industry. Right? It has come to us. Right? So employees rich. Right? In any country which is rich, output per employee is high. It is the human productivity, when it goes up, the societies become rich. Of course, human productivity does not come only through the work of the human. It comes through the work of the machine. So if you are able to create more and more powerful machines, less human input is required, so per man output goes up. You should not think that increasing human productivity is not through the more and more output from an individual. Right? That is physiologically limited. Right? How many kilocalories per minute we can expend? Right? There is some limit. Right? Suppose you say 5 kilocalories per minute we can spend. You can get a work output from man only of the 5 kilocalories. You cannot get 30 kilocalories per minute. But in that 5 kilocalories that the man gives per minute, you should be able to get the maximum. That's why you are trying to talk of the machines, giving you a lot of advantage. Right? We normally talk in terms of the mechanical advantage. I provide a less force, but it gives. But other advantages are also there. Because you are giving machine energy, electricity energy, you don't have to use the energy. Right? The energy is put through it's different source altogether. You are not able to put through energy. Right? So every expenditure made or proposed has to be economically justified. Either a short-term expenditure or a long-term expenditure. Right? That's the point I already said. Industry engineer to evaluate the other engineers' proposals. Then we are coming to the human effort engineering. Right? This way we are talking of the motion study, principles of motion economy, fatigue study we need to do. We said 57% rest and 43% is the working time that you are going to do. Economics, you have to make sure job evaluation and wage incentives. Then there is engineering activity. You try to design a new type of hand tools which are going to increase productivity, which are going to reduce jig and fixes is the one simplest example in the mechanical field where you are trying to create so that the man is going to spend less time in loading and unloading the jobs. Right? Right? We already said this particular thing. Measurement is important. Right? Cost is also an important measurement. Productivity is also an important measurement. We need to do that activity. Right? Then comes the productivity management. Right? Industry responsible for managing industrial engineering studies, projects, and IE department. That is your own department management. You do a study, you need to manage that particular this one. Right? They are responsible for managing productivity and cost. Both of these things are under you. Right? Then we said, if the management processes are giving rise to low productivity, right? You need to change them. You need to understand the management processes, right? So that you try to change them whenever they are giving a less productivity, right? So these are the IE studies, various management subjects are taught. I would say the first purpose of teaching you a marketing management is not to make you a marketing manager. If somebody is MBA marketing and I am doing one subject on marketing and I want to claim, okay, now I will become a marketing manager. That may not be the right sort of a conclusion. The marketing is taught to you so that you understand the marketing process and improve the marketing process from the productivity and efficiency. Various management subjects, when there's a basic subject is taught in your particular course, the focus is to be on that particular aspect. In this regard, what I did was I requested all our faculty members through an email and said that all of them should frequently discuss, right, what is the relation between the subject that they are teaching and the industrial engineering theory and practice. That particular linkages should be repeatedly brought out so that we understand what exactly is the major object. The minor object could be anything. My PhD is in the stock market. And I actually went and worked in a broking company for 1 year as a vice president training of Mutri Laws for Securities. And I worked as a senior professor of finance in ICFA. So limit is not there. The issue is limit is not there depending on the individual interest and depending on what growth path you have taken, you are going to be subject. But from a curriculum angle, from a course angle, from a discipline angle, what exactly is the focus of industry? That has to be brought out very, very clearly. This is a point I was just written 2 days back, a biography of a Japanese industrial engineer. Right? He died in 1957, it seems, and in the very end of that it says, he prophesied that we Japanese are going to export industrial engineering to America. They imported the industry to America and then Japanese have become the re-exporters of that particular trade. The entire lean movement is export of the Japanese management technology. Now same thing can happen in India also. We can also dream that we are also going to do that sort of a thing and any of you could be the person who could be doing that particular thing. Because you see only 2-3 Japanese names. As great people, Taichi Wano, Shingo, right? These are the 2 names that everybody talks about. So it becomes a sort of an individual effort and an individual achievement which becomes worthy of emulation by the world. So you should really have that sort of a dream or have that sort of a goal that everybody is talking of, have big goals. Right? So let us begin the PG46 journey with a big hope and a commitment to learn. Right? In your first class, I will just give these links of blog links I will send you. Please read those 2 things and come. We will discuss in detail. We will start with the class with this. Right? What is the Taylor has written on the scientific management innovation shop and what is the lean philosophy and the industrial engineering philosophy. One thing is the IIE, Institute of Industrial Engineers, which is the global body of the industrial engineers. It has very active communities on LinkedIn and Facebook. So I request all of you to join them because